Hello everyone. Today we're going to look at how to factorize quartics equation, and later on we're going to revise how to solve the quartic equation as well. Now here I have the general form of quartics. Now depend on what's the coefficient here that we have different methods. So mostly we would look at the coefficient. Sorry, the constant is a. So if a equals 0, so basically you didn't have any constant, okay, no constant, then you would need to take out the highest common factor. So I'll give you an example. If I have something like x4 minus 3x squared minus, sorry, x4 minus 3x cubed minus 4x squared. So you can see I didn't have any constant here. So what's the strategy to factorize this? This means if you have no constant, then the best way is take out the highest common factor, okay, which is x squared. They all have x squared as the highest common factor. Then x4, if you take x squared out, you have x squared left minus 3x cubed x squared here, so you have 3x left, and then minus 4x squared, the x squared have been taken out, you have minus 4 left, like that. Then you just need to factorize further by sorry, make it smaller, by finding two numbers time together equal -4 and add together to give you -3, which you would have -4 and +1. Okay. Now, if you do have the constant here and the constant here not equal to 0, so if a is not equal to 0, this means you has a number, a constant that not equal to 0. So an example for it can be something like x4. Let's say I'm going to use different pens. So x4, okay, my plus x cubed minus 7x squared minus x minus 6 plus 6, sorry. So you can see I have a constant here is 6. So how do I factorize this? Your first step is you're going to find a factor of 6 first. Okay, so find a factor of 6, and factor of the 6 will be plus minus 1, plus minus 2, plus minus 3, and plus minus 6. So you're going to do a bit of trial and error here. You're going to substitute the x value in and see which one will end up equal to 0. So if I try x equal 1, then I sub 1 in. So 1 4 plus 1 cube minus 7 times 1 square minus 1 plus 6. So I have 1 plus 1 minus 7 minus 1 plus 6. That luckily give me 0. If it didn't give you 0, then you have to try -1. And then if it didn't work, then try 2, and so on. Okay? Because you substitute 1 in, it's end up equal 0. So you would say x minus 1 is a factor. All right. Then your next step is you're going to find a quotient. So the next step is you're going to do long division like that using the table. So here you're going to list out all the coefficient of quartic. So you have 1, 1, -7, -1, and 6. So you write here 1, 1, -7, -1, and 6. So these are all the coefficient of the quartics, okay? You divide it by x minus 1, then you turn x equal 1, all right? Then if you watch the other video, we talk about how do we use long division for this method. So whatever one here we bring it out, okay? Then you do 1 times 1 plus 1. 1 times 1 is 1, 1 plus 1 equals 2. Then doing the same thing, we do 1 times 2 plus -7. 1 times 2 is 2, 2 minus 7 is -5. Then keep going, 1 times -5 is -5 plus -1 gives you -6. And finally, 1 times negative 6 plus 6 give you 0. And of course, the remainder is 0. So you know you are doing correctly. All right. So this means when you write the answer, you would write, so x equal 1, you would write that as x minus 1. Then you can see these are the coefficient of a cubics because quartics divided by a linear that gives you a cubics. So you would have 1x cubed, okay, plus 2x squared minus 5x and then minus 6. There you go. So you reduce from a quartic initially to a linear and a cubics. Then your next step is you're going to factorize the cubics here. Okay. So step 3 is I'm going to factorize the cubics that I have here. And to factorize the cubics here, you do have the constant of 6. So you're going to try again using, the trial methods. So factorize cubic. So to factorize cubic, I'm going to find the factor of negative 6, which is plus minus 1, plus minus 2, plus minus 3, and plus minus 6. Okay. Let me just write the cubic equation here, ax cubed plus 2x squared minus 5x minus 6. All right, now I try 1. So if you try 1 in here, x equal 1, you would have 1 cubed plus 2 times 1 squared minus 5 times 1 minus 6. That does not give me 0, does it? No. If you try x equal negative 1, you have negative 1 cubed plus 2 times negative 1 squared minus 5 times negative 1 minus 6. Negative 1 squared times 2 is 2 plus 5 plus 6 minus 6. This will give me 0. So because you sub negative 1 in the cubic and it's end up 0, so you turn the negative 1 to the left, that's become plus 1. So you would say x plus 1 is a factor, all right? And then you will do the same thing. You're going to do the table to find the quotient. So you have 1, 2, negative 5, and negative 6. You write here 1, 2, negative 5, and negative 6. Okay, and x equal negative 1. You write here. Then the one you bring it down, you do negative 1 times 1 plus 2. That gives you negative 3. Then negative 1 times, negative 1 times 1 is negative 1 plus 2 is 1. Then negative 1 times 1 is negative 1 minus 5 is negative 6. And then same thing, negative 1 times negative 6 plus 6 gives you 0. So you would have here as x plus 1. And here you're going to produce a quadratic inside. So it will be 1x squared plus 1x minus 6, like that. Okay, so this is the cubics here can be written as this, right? So now you combine, so in the second step, you know that so this is the whole cubics here. And in the front, there's x minus 1 in the front. Okay, so I just need to insert the whole thing here. I just need to insert x minus 1. All right, that's give me a quartic altogether. Then my last step is literally I just factorize the quadratic inside. So two numbers times together equal negative 6, add together equal 1, which is positive 3 and negative 2. So there you go. You actually factorize into 4 linear factor. Okay, so if we follow these methods, we pretty much can do for any equation. So no constant, we take out the highest common factor. If it has a constant, then we do a factor, we draw a table, we get a cubic here, then we continue factorize cubic and doing the same thing. We get a factor, we draw a table, then we get into a quartic, then we factorize again. So it's a whole, process of um, making the degrees to be smaller. Okay. Now there's some special way to factorize quartics. So there's special way here, special methods. Now, and these methods only work if this happen. Okay, these methods always work if you have no constant. The constant equals 0. These methods always work. If you have constant, then these methods always work. But the special methods is in some cases. So special methods, the first factorizing methods is if you has three terms, all right, which is x4, x x squared, and the constant. So technically, you are having the x4 term, the x squared, and the constant. So let me just write that as ax4 plus cx squared plus a. So if you have three terms like that, then what's the y? So if I have something like x4, right, minus ax squared minus 20. Okay, so theoretically, you could do, if you have a constant, you could do the long way like that, but I'll show you the quicker way. The way that we do it is if you see x squared, and you can see there's x4 here, and the relationship in between them, if you do x squared, if you squared it, you get x4. So what we do is we're going to let x squared equal a. Okay, so we let a equal x squared. So a to the power x to the power 4 will become a squared, like that. All right, so a is x squared. Now, so we have a squared minus 8a minus 20. Then we actually convert from quartic to a quadratic equation. Then we factorize this. So time is negative 20, add is negative a, which is negative 10 and positive 2. Then after you do that, you put a back at x squared because you want to do factorize for x, not for a. So x squared minus 10, and a here you replace at x squared plus 2, like that. There you go. Then you factorize further, x squared minus 10, you can use the dots. So x minus root 10, x plus root 10, and x squared plus 2, there's a plus in between them. You cannot factorize that. Okay, there you go. So this is a lot faster than previous one, but it's only work if you have three terms, x4, x squared, and the constant. All right. One more method is if you have four terms, okay, and they have the same ratio between the first two terms and the last two terms. So let me give you an example. If I have something like x4, right, minus 6x cubed, something like that, and then minus 2x plus 12. So how do I know that I apply this method? So I check the ratio. You can see x4 divided by x4 divided by 6x cubed. Then you check with negative 2x and 12. So you can see 1 over negative 6 is the same as negative 2 over 12, right? And x4 over x3 is technically 1x. So for this method, for the strategy of this method, all you do is you just need to do grouping. So you group 2 by 2. Okay. So you group this and you group this. You take out the highest common factor. The highest common factor here will be x cubed. You will have x minus 6 left. Then the highest common factor here minus 2. Then you have x minus 6 left. And because you can see they have the same ratio, so inside the bracket will be the same. So you take x minus 6 out as a common factor. Then inside you would have x cubed minus 2. There you go. So this is a lot faster than using the traditional methods. Then you look at this, then you think, oh, I can go further if I look at how to factorize cubic is a cube. So if you recall the formula, a cubed minus b cubed is a minus b times a square, right, plus ab plus b square. So you can go further with this. If you just make 2 as cube root of 2 and then cube like that, and x cube you write again. Okay, so a is x and b is cube root of 2. So you would have x minus cube root of 2, and then you would have a square will be x square plus cube root of 2 x, and then plus b square is cube root of 2 square is cube root of 4, like that. And x minus 6, you just write again. So you have x minus 6. So pretty much that's the methods or methods we use for quartics. So summarize, no constant, we take our common factor, have a constant, we use a factor, we draw a table. And if we have 3 terms, x4, and a, then we convert to quadratic equation. And if we have 4 terms with the same ratio, then we do grouping. Okay. Now I want to talk about solving equations. So let's do number 2 is solving quartic equation. Now with solving, so if you have the in the turning point form, so if you have something like 4x minus 1 to the power of 4 minus 2 equals 0, something like that. So if you want to solve for x here, and there's no other x, so the method to do this type question is you just move everything over and solve for x. You don't need to factorize, okay? So you have 4x minus 1, 4 equal 2. Then you put the 4 over, x minus 1 to the power of 4 equal to 4, which is 1/2, like that. Then x minus 1, when you fold through the other side, you always have two answers, plus and minus. So plus minus 1 over 2, okay? Then to move the 1, you just plus 1 on this side. So yeah, plus 1 here. And then you're done. Now, if it x in one place, you just do like that, all right? Um, if you end up having one of these equations, then the best way to go about it, you need to factorize. So let me give you an example. If I have something like x4, okay, minus 6x squared equals 16, something like that. So my first step that I want to do is I need to turn the 16 over first. So x4 minus 6x squared minus 16 equals 0. So you always need to make sure one side equals 0 first before you move on. Then you look at this and you say, oh, this is quartic, and they have 3 terms, x4, x squared, and the constant. So I know that I have to factorize. And how do I factorize? To factorize x squared here, you're going to let that equal I. So let I equal x squared. So I can turn to a quadratic equation, okay? So you would have x4 become a squared minus 6a minus 16 equals 0. Then you can factorize. So times negative 16 as is negative 6 is negative a and positive 2 equals 0, okay? 8 is x squared minus a x squared plus 2. All right. Now, because this is solving, so technically you can just apply the no factor law from here and solve them individually if you don't want to factorize further. So I would have no factor law x squared minus 8 equals 0, or x squared plus 2 equals 0, like that. So you would have enough x squared equal 8, x equal plus minus root 8. which is plus minus 2 root 2. And x squared equal, on the side x squared equal negative 2, which is impossible. You can't, something squared can't be negative. So you have two solutions. Okay, so generally speaking, with quartic equation, if you want to factorize, you on way. If you want to solve and there's multiple position for x, you on way factorize. So on way go back to the previous methods of how do we factorize and different methods. Okay, then you can, after you factorize, you can apply no factor law. And if x in one place, like this question here, you don't have to factorize. You just move everything over and make x as a subject.